From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 394, recorded live Thursday, October 17th, 2013. This episode of Hansel Minutes is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, makers of GesturePak, a powerful gesture recording and recognition system for Microsoft Kinect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Dianne Marsh about the rise of Scala.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I'm talking to Dianne Marsh from Netflix, Director of Engineering for Cloud Tools. Thanks for chatting with me today.
Thanks, Scott. Glad to be here.
I was really happy to have another Netflix person on, talking about Groovy on Grails a couple weeks ago, Clay McCoy. But you are a Scala fan. Talk to me about Scala. That sounds really like I need a PhD to use.
Well, funny you say that because that has sort of been the myth perpetuated in the community over the last couple of years. I think it's starting to change. As you know, I approached Bruce Eckel about writing a book about Scala a few years ago for the sole purpose of helping to debunk that myth. Mm-hmm. We had been hearing over and over and over again, Scala's hard. It's too terse, it's too Perl-like, and that hadn't been my experience at all. So I'm friends with Bruce Eckel, and I was at a conference with him, and I just approached him and said, what do you think about me writing a book on Introduction to Scala, sort of letting people know that Scala is not hard and showing them my experience? And he paused for a moment, and he said, I'd like to help you write that book. Which was, I know, incredibly generous. You know, I that wasn't really where I was going, but wow, blown over by the suggestion and by the generosity.
Well, and people who don't know who Bruce Eckel is, he is the author of Thinking in Java and Thinking in C++. And I might go so far as to say thinking in curly braces. So I'm surprised he was so enthusiastic about Scala. I mean, I know he's a programming language enthusiast and has done lots of lectures and is arguably agnostic in his understanding of and belief in programming languages. But wouldn't you say that Java and C++ and those kind of languages are different than Scala? Scala feels different. It is more Perl-like, and it has it's not either of those languages.
I think it's on the evolutionary scale. I think what we're seeing is that programmers like me started with C and moved to C++ and then moved to Java, and played and toyed with C# for a while because I thought that was fun and interesting. But I really found my home in Scala, where I found that the expressiveness of the language, the fact that I don't have to write all the boilerplate code, relieved me of a lot of the annoyances of writing in a language that was developed a very long time ago.
So you think that it's some of the historical baggage that causes us problems as we try to solve new problems in languages that have like 40 years of curly brace baggage?
I think so I have some strong opinions about this. I think that some of the newer developers come to us having learned Java in college and having used Java in their jobs for years and years and years, and never having experienced the migration to a new programming language. I think that they've forgotten that Java, the language today, is not the same language that they learned in college. It's evolved with them. They've grown with it. They've learned how to bring in libraries that did amazingly great things and made their lives simpler. So they've sort of eased into the language, but it was still called Java. So you put a new language in front of them, Scala, and you add a functional programming paradigm on top of that. And now it seems really scary and different. And I think that part of the problem is that we've sort of, as an industry, lost our muscle in learning new languages. And I feel like that's part of the problem here. It's different, it's new, and it's scary. And then when we add the functional aspects on top of that, it gets even more scary, right?
When someone looks at Scala, remembering, of course, that we're on a podcast, what are they going to see? If they don't know that Scala exists, are they going to say, oh, it looks like Python, or, oh, but that doesn't look right. That's not Python. I mean, what does it feel and look like visually?
Yeah, I guess it probably looks a little bit like Python. It looks a little bit like Java. Some things are a little bit disconcerting about it because the variable declarations, so the type of the variable follows the name of the variable, so it's variable name colon type, and which really helps with type inference, right? So what you're buying is type inference, and what the cost of that is you're seeing a slightly different syntax.
Is that required? If I say var foo, do I have to say colon type?
No, you don't. In fact, most of the time when you're writing Scala code, you won't necessarily define the type. You'll normally use type inference. Where you'll see the types is mainly when you're defining either classes and you're talking about the arguments or the parameters for that class, or when you're defining methods on that class. You'll see the types for methods and you'll see the types for class definitions. You'll also not see a constructor because it won't look like you're seeing a constructor, because when you say class foo, and then a parentheses, and you list out your parameters, that becomes your class definition. And it buys you a lot of things. It means that if you have variables defined, parameters defined to that class, those become either private or public fields in that class, depending on how you've defined them. So you get your getters and setters for free, for example.
Okay.
And so this is something that just needs to be pointed out to you once you see it. It's really cool. You may look past it, though, and not see it initially.
I see. So in something like Java or C#, I'll say public class point, and then have private X and Y, and then have to go and hook up the getters and setters for the public properties of X and Y. But in Scala, I just say class point and then val X, val Y, and I just had 10 less lines of code, really.
Yeah, and so it may seem subtle, but when you said val X, val Y, now you get just the setters, and those are immutable variables. If you say var X and var Y, now you've got variables, and those become those define both getters and setters.
Wow, that is a subtle one letter change there. Val versus var has completely huge semantics that kind of ripple through the system.
And if you leave it off entirely, then what you're getting is private fields.
Really? So if I just say foo equals 1, that's just a private, and it's kind of inside of the class and scope to the class? Yeah,
so if you say class bar X colon int, for example, then that X is private to that class.
So it doesn't seem like it's as verbose as and again, I kind of think about the C heritage of languages. If you look at an example program in Java, the Scala one is about 2/3 the size.
Or less, maybe 1/3 even.
Really?
It's significantly less in size. Even to the point where, in Java, if you're declaring a variable, you have to declare the type on both the left-hand side and the right-hand side, right? You're newing it on the right-hand side. You're declaring the type on the left-hand side. In Scala, you're just saying var blah equals list 1, 2, 3, right? So you're only saying list once on the right-hand side, for example. There are even simpler ways to do things like that. So lots of verbosity is removed from the language. Oh, and you do get to leave off your semicolons. So
don't tell Douglas Crockford. So the semantics are there, though. You've removed the sugar, but the meaning is still there.
Right. And it does compile down to Java bytecode. So what you're getting at the end of the day is an application that runs on the JVM. And you're getting a lot of compatibility with other languages that are on the JVM, calling into other languages from Scala, calling Java from Scala, Scala from Java. There are some tricky things that you need to be aware of when you do that. But, for the most part, that's something that you can do, and you can kind of sort of evolve your code in your libraries to reflect the fact that you're using a new language, but you don't have to go wholesale and rewrite everything.
Interesting. So if I'm doing a lot of type inference and then suddenly I reach a boundary where I have to kind of move into some Java or some existing Java classes that I've already written, what do I have to do? Do I have to say as instance of and then kind of cast my dynamics down into something that Java is going to understand?
No, because you're using the Scala compiler, you're able to bring in those classes without in sort of native Scala syntax. The only difference is that you're bringing in Java classes, so you may run into some boundaries around null pointer exceptions, which we wouldn't normally see in Scala. So you just have to be a little bit careful about that. But as far as you're importing a Java class in the same way that you would import a Scala class.
Okay, so that's on the consumption side where a Scala class wants to consume Java. What about if Java wants to consume Scala? Do I have to then add the annotations and type annotations at that layer?
Yeah, then you're in Java code, so then you're going to have to follow all of the Java restrictions about what you're, how you bring in the Scala classes.
Mm-hmm. But Java arguably doesn't really care.
It doesn't know. It's the same as bringing in any other JVM language.
Okay. So you can, and I understand that you could even, this is operationally, it behaves like Java because ultimately it is Java. It's in the JVM. And as far as the JVM is concerned, Scala code, Java code is not distinguishable.
That's right. And then, so one of the things that you get now is the ability to be able to migrate your code, sort of on a piecemeal basis, write new code in Scala, and leave your old code in Java. And that's a nice approach some people take. Sort of, I think it would be unrealistic to expect that people would greenfield everything, right? And so this is a really nice step into Scala land. Another really nice step into Scala land, to sort of build confidence in your team around learning Scala is to use Scala Test. And Scala Test is a testing framework that Bill Venners wrote, and it allows you to actually test your Java code using Scala Test. And it's a nice BDD approach, and it's a really great framework in its own right, but it also gives your team sort of some experience with writing Scala tests where it's not in production code. They don't have to feel concerned about, jumping wholesale into the language, but yet they can get that experience with Scala in that sort of a comfort level. And some teams have found that they liked Scala tests so much that they've decided to go into Scala for production code as well. Sort of they got that confidence. They're like, hey, this isn't so bad. And that's really what I've been trying to promote is the idea that it's not that scary. And even if you use Scala as a better Java, it's better than Java. I think you probably remember, as I do, the biggest insult you could levy at someone when they were going from C to C++ is, oh, you're still writing C and you're using a C++ compiler. Yep. And so I think we all feel a little bruised by that, right? And like we're ready for the shoe to fall where people are saying, you're writing Java and using a Scala compiler. It's okay. Yeah. I think that their code will become more idiomatic as they get experience with the language. Yeah. Even if you don't use any functional aspects to start, I have to say that it's enchanting. You get more experience with the language and you learn more about it and you start saying, gosh, I could just use immutable variables here because it's the variables are immutable by default, right? So if I start using immutable variables, then I learned how to restructure my loops in a different way. And I learned maybe I start heading down the path of doing more recursion, and it sort of spirits you in and you learn it at your own pace. You don't have to jump in and be like, oh, I'm all functional today, You can really sort of ease yourself into the whole experience.
Yeah, I think that learning another language is one thing. Learning to write poetry in that language is another thing. Like someone asked me how well I speak Spanish, and I said Chipotle. because that's about how well I speak Spanish. You know what I mean? I can order food, but I am not writing poetry. And I feel the same way when I start learning a new language. Like, can I order food in F sharp? Sure. Can I write poetry in F sharp? Probably not. But if the language is structured in such a way that I could say, all right, I'm going to go ahead and switch from Java for each loops to the Scala for expression. And I'm going to do that in a non-threatening way. In C sharp, another example would be like, really starting to embrace link. You can write idiomatic, tight, clean, poetic looking link expressions, or just don't do it at all. You get to pick and choose. So it's good to know that you don't have to go whole hog into Scala world.
I think that's a really great example because I learned link in C sharp at sort of around the same time that I was learning Scala. I was sort of playing with link at the same time, and I saw a lot of similarities between the two.
Mm-hmm.
And I found that, as you learn those concepts and those idioms about how to use something like link or functional programming in general, you start applying that to all of the code that you write, and you sort of bring that into your toolbox. And I think it makes all of us better programmers when we just have better, different tools that we can apply in situations that we find them necessary.
I think this is important for younger programmers, and I don't mean by age, but in experience, younger programmers to remember that there are a class of programmer out there that have been writing for loops and switch statements and while loops for 20 years. And, got a problem? Let's write 3 nested for loops. And then you show them something like in using a for expression example in Scala, say for something, one to something, if there's a case, yield. And then, whoa, wait a second, you just took my nested for loop and turned it into one line. That's too much. If you can make that semantic jump out of just kind of classic procedural, because you're effectively writing basic. You know what I mean? You're writing the basic that you learned when you were 13, except now you've been an engineer for 15 years and you keep writing these same for loops over and over and over again. Try to pick one problem and solve it in an idiomatic way. And then that's now in your toolbox, and you'll recognize it in other languages.
Yeah. And then I think the for expressions are a great example. And, people that are familiar with link, I think will find for expressions in Scala quite comfortable because there's a nice sort of comparison there. Another really great thing in Scala is match expressions. Match expressions take pattern matching, all the way to 11. With pattern matching in Scala, it's interesting you mentioned the naive programmer. I remember when I first started using case statements, I guess it must have been, I don't know whether it was called case statements in C or Pascal or whatever, but, sort of the equivalent of doing pattern matching back then. I had this sense that we should be able to match on things that weren't ordinal values. I wanted to match on all kinds of things, and I was too naive to realize that I couldn't do that. So I tried to do that. And of course the compiler, whacked me and said, you can't do that. You have to use ordinal values for match expression, or for, in that case, pattern matching. Scala relieves you of that. So in a sense, it takes me back to my youth where, I was naive enough to think I should be able to do this. And now I can, and so it's really great to have features like that emerge in the language. And the fact, I guess that's where I see Scala as part of the evolutionary scale. There have been a lot of advances in language features and a lot of advances in how we build languages and how we pull concepts together. I want the benefit of that work that's happened over the last 20 years. I don't want to stay with languages that were, prior to that on the evolutionary scale.
Yeah. The case classes and pattern matching in Scala does so much in so few lines that it's one of those things where I feel like if you're like learning Perl, where you just have to stare at it for a minute and just wait for the knowledge to come. I saw a quick sort algorithm done using matches and cases in Scala, and it was like 6 lines of code, and it's just like, what is happening here? I don't. You know what I mean? There's so much in such a short amount of space.
Yeah, I think what I've been asking people to think about is that terseness. Like, where is it too much? And I think it's really important that your team be able to read your code. It's really important that other people be able to read your code. And it's really important that you're able to read your code when you come back to it after vacation.
Yeah.
Right? So writing something in the most terse format ever is not the goal here. Write your code to be readable. And you can write readable code in Scala.
Yeah.
And I think a lot of what we saw and a lot of damage that was done or that can be done in any language with early adopters is that the early adopters get very excited by how terse they can make their code. Look at the cool thing I can do, right? And so then that becomes what's on Stack Overflow. That becomes what people find when they're searching on the internet. And those are the examples that they see. And they're like, oh, no, it looks like Perl. But it doesn't have to. Those are just what the early adopters were doing, right? And so it was a bad representation. Yeah, it was cool, but it's not the code that you want to write for production.
Right. When those are unfortunate things that when the early adopter enthusiast sees it and then starts to push on it to see how far it can take it. The same thing happened with Link, where it's like, here's a ray tracer in one line of code. It's like, oh, no, this is impossible. What am I going to do? It's great that they did that, but for the newbie to go and look at that, it's difficult. And I think this is a larger problem than with functional languages, because people who like math and the expressiveness of math and understand math at a cellular level love writing terse equations and small proofs and things like that. Whether it be Scala or Haskell or F#, it's like, how small and efficient can I get this to look like a mathematical function? How does someone make that jump from procedural to functional when there are these barriers that stand in the way?
Yeah, I think those barriers are in our own heads, right? And I think that, it's that muscle we're not exercising. And it was funny because when we first started writing Atomic Scala, we thought maybe we'll have 2 volumes. Maybe volume 1 will be object-oriented Scala, and maybe volume 2 will be functional Scala. And as we started writing the book, we realized that we were bringing our own bias as developers with lots of object-oriented experience into the book. So we were writing a book for beginning programmers and thinking, hey, they may not have experience with object-oriented programming. So why are we perpetuating this idea that object-oriented programming is easier than functional programming when all of us know how to do math and how to represent mathematical equations? It may actually be the case that people are just as able to adopt functional programming as a concept as they are, or maybe even easier than they are to adopt object-oriented programming. And for example, I suspect that my husband, who's an engineer and a laser scientist who writes programs in MATLAB all day long, would find Scala much easier than what he would than Java or C# or C++.
Isn't that because when you're writing something in a C family or procedural language that you're writing a series of steps? Now do this, and now do that. Now do this in a loop. While when you're doing something functionally, you really have to, I don't want to insult anybody, but you have to really understand the problem. Like when you're doing something procedurally, you can just kind of step 1, step 2, step 3 didn't work out. I'm going to just back up and try a different step 3. Well, when you do something functionally, you have to really get what you're trying to do. You have to really understand the problem from end to end and then express it in a function. Like if you think about recursion, like that was one of the big things in computer science class that early programmers, like you either get it or you don't. And then one day it clicks. But you have to really visualize and internalize and grok what's happening. And I think that a lot of people don't really know what they're trying to accomplish when they sit down and they start typing. You know what I mean?
Yeah, maybe we should step back from the keyboard a little bit.
That right there. I mean, I think that languages that are expressive and terse like this require an understanding of the problem space that requires sitting quietly with your hands at your lap, not on your keyboard, thinking about what the problem I'm trying to solve is, especially when you get into issues like concurrency.
Yeah, and I think I think that there are some functional programming languages that are unapproachable because you have to really grok that functional aspect before you can be productive in a language. And what I liked about Scala was I could ease into that water. Mm-hmm. I could still write my very procedural code in Scala. The experienced Scala programmer would come back and say, it's not very idiomatic.
Right.
But I can get better. I can learn, and I can watch what other people are doing, and I can grow my functional sort of muscle back. I used to think recursively, right? Back when I was in college. I stopped thinking recursively
Mm-hmm.
as I got older and, potentially more lazy, in my, like you said, I continued to write the same code year after year after year after year,
Mm-hmm.
And I stopped exercising that muscle. I think it just takes a little bit more time to get that back and to start thinking, once you kind of understand the way recursion works, it's pretty obvious,
Sure.
And so it's easier to decompose the problem, but you have to really remember the secret of how you're actually looping through things and, calling with previous state, as part of the method itself. And I think that it's a way of thinking that we've become inexperienced at using.
Mm-hmm. There's a kind of developer that I gave an archetypal name to. We call them the dark matter developers. They take up most of the space of the universe, but we can't prove that they exist, just like dark matter. And while there's so much enthusiasm around the JVM kind of derivative languages like Scala and Clojure and Groovy, and it seems like everyone who is smart and loud on the internet is doing those things, if you look at the math behind it and the actual like popularity, Scala doesn't even break the top 30 languages. It's down there with Erlang and Prolog and Haskell, which are great languages, but the dark matter developer doesn't use them. Java is got popularity right now. Mm-hmm. Why is it that loud, enthusiastic, smart people talk about languages like Scala and Groovy and Clojure while the enterprise person just keeps banging out JSP pages?
Gosh, that's a hard question to solve, because when you have the mentality that you joined this industry because it was evolving and ever changing, and it was basically a dedication to a career of learning. Mm-hmm. It's hard to identify with people who are perfectly happy doing what they were doing 10, 15 years ago.
Right.
It's absolutely impossible for me to put myself in their shoes. All I know is that I am fairly lazy in programming, in terms of I'd rather write less code and spend more time thinking about the problem domain. Mm-hmm. And so I think that the newer languages offer me that ability. Mm-hmm. They also let the problem that I'm trying to solve emerge from the code more readily and make that more apparent when I'm looking at the code, because it's not hidden by all the boilerplate. And so for me, it's easier to solve these problems using newer languages because I get to hide away all that cruft that was taking up space in my brain.
You're right.
But I think that there are a large number of people that will never touch, who are perfectly happy, who don't listen to this podcast, who don't listen to any podcasts, who don't go to conferences, who are perfectly happy doing programming 9 to 5 and not thinking about it on the weekends. Mm-hmm. And never really thinking about where their career is going, because they have a job. And their job is to write Java code. And when Java becomes the language that nobody uses anymore, then they'll be unemployed, and then they'll learn by the very necessity of learning a new language so that they can get a job again. They'll learn whatever new language it is. Then they'll get another job, and they'll repeat the same mistakes over and over again.
Is there a kind of an implicit value judgment in that? I mean, there kind of is. I mean, we're not saying that it's not about punching out at 5 o'clock or not. I mean, you can have a very good career and a successful career not thinking about these things on the weekends. But I think when you said thinking about it on the weekends, you're really talking about it's like if you're a craftsman who makes things with wood and you watch like the Yankee Workshop, it's like it's something that you're so excited about, and you're always thinking about new and effective ways to make wood and make the wood bend to your will because you just love it. Is this the difference between just loving computer science and software engineering and just kind of like, it's a job?
Yeah, I think it is. I think it's that the person who loves computer science and software is the person who can't turn their brain off, right? And so I'm not saying that I go home and work all night long and that I don't have a life, right? I think especially one thing I notice here at Netflix, because we tend to hire developers who have experience, mm-hmm. We don't have a culture that really has people coming in and staying through all hours of the night. What I've seen here is that people tend to arrive around 9 o'clock after they drop their kids off at school. They tend to stay until 5 or 6 when they're going to go pick their kids up from school. And then they go home and they do some more work. But if that's what they need to do for their job, they work really super hard when they're here.
Mm-hmm.
And then they go home and they don't shut their brains off. They may not actually be fingers on keyboard, but they're thinking about interesting problems and they can't help themselves.
That's cool. I guess if you're going to have a dysfunction, that's the right kind to have.
Yeah. So.
Well, it sounds like it's really exciting, the stuff that's happening at Netflix. And thanks so much for talking to me about Scala and for having Clay on to talk about Groovy. And people, of course, can follow you on Twitter and learn more about your stuff, as well as go up to GitHub and see all the great things that Netflix is putting out into the open source world.
Yeah, it's really exciting and really fun. And, it's part of us giving back to the community for having used a lot of open source in our software. And really helping to help other people adopt the cloud. So it's a pretty fun 35, I think, projects now out on GitHub, including one of Clay McCoy's, who you talked to a couple weeks ago. One of his projects is out there called Glisten. So pretty exciting stuff.
That's fantastic. Thanks so much, Dianne Marsh from Netflix, for talking to me today.
Thanks, Scott.
This has been another episode of Hansel Minutes, and we'll see you again next week.